Yesterday we talked about discontinuity, okay, and also what made a function continuous. Now, we talked about all 8 parent functions, correct? Okay, out of the 8 parent functions, which ones were not continuous? With the raised hand, Jordan. Reciprocal was 1, and greatest integer. Out of all 8, those 2 were the ones that were not continuous because they either had one of the 3 types of discontinuities. What is one of the discontinuities? Jump discontinuity, also known as a removable discontinuity, which is a hole. That will be jump. One more. Infinite discontinuities, which are your vertical asymptotes, okay? So your reciprocal function had your infinite discontinuity and your greatest integer had the jump discontinuity. Now piecewise functions, depending on exactly what type of piecewise function you have, those will also be, could also be discontinuous, okay? So do be aware of that. What we're gonna do today is we're gonna go back over continuity a little bit more, and then we're going to finish up the lesson 7 notes, okay? So, out of all of these options, there is actually one of those that is continuous. A, B, C, or D. Which one is continuous? Brad? I see. Stop. It's D, because D is what type of function? It's a cubic. And cubic is one of the parent functions that is continuous. Okay? So D was a continuous function because it was cubic. All cubics are going to be continuous, just like quadratics are continuous, just like absolute values are continuous, just like linear and constant are continuous, and square root. Okay? So, A, B, and C are all a part of which family? Who's their parent? The reciprocal function, okay? Reciprocals, you always need to check to see if there's discontinuity, okay? Now, if you watched the video, raise your hand if you watched the video. I talked about how to figure out if you have a removable discontinuity, didn't I? I did. Do you remember what I said? Like I sat up here and I said, you'll know that you have removable discontinuity if something cancels out with the top and the bottom. And yes, you did learn that last year. Yes, you did. Yes, you did. And we went over that yesterday. We did go over this yesterday. So, bump that. We went over this yesterday. So, B is the only one that's going to cancel with something. Because look at the top. What can you do with the top? The top factors down to be whenever a factor cancels out, okay, with the top and the bottom, you know there's going to be a hole or a removable discontinuity. And that hole is located at -2. This is how you figure out where the holes are located. You set the factor equal to 0 and you solve. Okay? So there's a hole when x is -2. So B was your answer here for your removable discontinuity. Now, A and C, those aren't continuous, but they don't have removable discontinuity. Look at A. What type of discontinuity does this one have? What type of discontinuity does A have? Think about it. It's going to have infinite. Because what is an infinite discontinuity? What was in the parentheses? Vertical asymptote. How are you going to have a vertical asymptote for a reciprocal function? What causes a vertical asymptote?
Whatever x can't be something.
Because
it would be undefined.
Because it will be undefined. What's going to make this undefined?
-3.
A -3. Because if x equals -3, that means we would have what in the denominator? A 0. So if you take the denominator and set it equal to 0, and you find that value that makes the denominator 0, then it has infinite discontinuity. There is a vertical asymptote at -3. Okay? Now I'm going back over this for those who were here yesterday and also for those who weren't here. Okay? So let's make sure we're following along. That's all I hand up. What about C? What type of discontinuity does that one have?
Same thing, but
The same thing. It has infinite discontinuity because what number cannot be in the bottom?
-3.
Because there's an asymptote there. It
So-
makes it 0. Yes.
So A and C differ from B because B had simplified first.
Exactly.
Okay.
And in A, I could not cancel out my x's, you guys. So don't think you can do that. It's x plus 3 at the bottom. Only thing I can cancel out would be another x plus 3. Questions?
Are you always setting, like, if it's in a fraction, are you always setting it to 0?
Yes, but you would do that if it could not be simplified, like in B. Okay, you see how B we were able to simplify? So we didn't have to worry about setting the denominator equal to 0. However, if we simplify and we still have a variable in the denominator, then we would set that. Okay? Yes?
So they cancel, it's always whole, meaning
Yeah.
always removable.
Yes. Okay? And if there is a denominator that has a variable in the denominator and it didn't cancel out with anything, you always know there's going to be a what?
Then
Asymptote.
An infinite discontinuity, an asymptote. Okay? So, with reciprocal functions, you can have two types of discontinuities. What are they? Infinite
And removable.
and removable. You know you're going to have infinite discontinuity if
If there is a variable at the bottom.
If there's a variable at the bottom, whatever's going to make the bottom what number? A 0. And you always know you're going to have a whole if
You can cancel out.
something cancels out with reciprocal functions. Yes.
What? Oh, never mind.
So, let's look at a different type of function that we know is going to be discontinuous, like a piecewise function. Okay? I talked about this yesterday. The first continuity test to help you determine if something's continuous is to plug in C into your function. And C, f of C has to exist, right? It has to equal a number. The second test says that the limit as x approaches C from the left and as x approaches C from the right has to be a number as well. If they are different, you get two different numbers. I talked about this yesterday. See who remembers. If they're different, what type of discontinuity do you have?
A jump.
Not whole, but
A jump.
a jump. Because that means that coming from the left and coming from the right, they're approaching two different numbers. Okay? So if they're different, say one's a 3 and one's a 2, you know there's a jump there. If they're the same, but different from the very first number, what type of discontinuity do you have? Removable. Okay? So with piecewise functions, you could have two different types. You could have jump discontinuity and removable discontinuity. It will be jump if you look at the left and the right and they are different. And then you'll have removable if the number from the left and the right is different from the number you got when you plugged in the C. Okay? Everything else will be continuous. Questions? And number one, what type of function was it? It was reciprocal. It was f of -2 over 3x squared, correct? And x equaled -1. You were trying to figure out if it was continuous at x equals -1. It's a reciprocal, so we definitely have to check. First test says to plug in -1. When I plug in -1, what do I get? -2. Is that a real number? Does that exist?
Yeah.
Yes, it does. So that is indeed true. So far it's continuous. Okay? Now the next two say to look at the function when I'm coming from the left and from the right. And for those who were not here yesterday, this looks like some type of curve, okay? Some type of reciprocal function. Okay? And specifically, I'm trying to figure out when x is -1. What y value am I approaching? Okay? So when I'm talking about from the left, this is what I mean. Like if I go along the curve, getting closer and closer to when x is -1 from the left, and then from the right. That's what I mean. What number am I approaching? Okay? Now I drew it that way for a reason. There is an asymptote here. Where is it located?
0.
At 0. Because 0 is the only thing I can plug in for x that's going to make it undefined. Okay? So all that asymptote occurs when x is 0. But when x is -1, it's still defined, isn't it? And no matter what, whenever I come from the left and from the right, I'm approaching the same number. So number 1 was continuous. Oh,
So you didn't need to do like step 2 or 3?
because if you did, you would see that they both would be -2/3, and everything would have equaled. Now if it said x was 0, then you wouldn't even gotten past the first step. Look at number 2. What was number 2? That was x equals what? And x equals. So you had to figure out if it was continuous and -4. First off, what type of function is this? Reciprocal, so you definitely have to check. When I plug in -4, that's the first test to figure out if something is continuous. I get -6 over 0. Does that exist? No, it's not. So the first test is not passed. If the first test is not passed, you don't continue. You just say it's discontinuous, and you tell me what type of discontinuity you have. Infinite. Because at -4, that is what's causing the denominator to be 0. And that is the thing that is making it a vertical asymptote. Questions? Number 3. F of x equals plus 3. And x equals. What type of function is this? Just like D was in the problem of the day. So you already know what? It's continuous. Because all cubics are continuous. And the last one, 4. What was it? X equals. What type of function? So you definitely want to make sure to check. What do you see here?
Factor.
I can factor the bottom, can't I?
Yeah.
To be what? And then leaving me with what? When a factor cancels out, that means it's a whole. Also known as a what? a removable discontinuity. And the removable discontinuity occurs at what value?
X like X equals
X equals -1. Whatever cancels out, you set that factor equal to 0 to find out that the whole occurs at -1. So this is a removable discontinuity here. What about a -2? If I plug in -2,
negative 2. Yeah, 0.
what will I get? Which is undefined. Does that exist? No. So this also discontinuous in -2, and what type of discontinuity do you have? Because I still had a denominator, and that value of x made it 0. You would have 2 answers here, because it's asking you at -1 and -2. So there were 2 types of discontinuities here. You had a whole, and you also had a vertical aspect. We're going to look at one more. And after that, I'll give you at least 7, 8 examples. Okay? Pull out your lesson 4 notes. Your lesson 4 notes. We never graphed this one in class. Plus 6 or minus 6. It was the very back of the lesson 4 notes, the last graph. We never graphed this one. So this is a perfect one to determine if this function is continuous at -5. So this is a piecewise function. I want you to determine if this function is continuous at -5. You've got to do the test for piecewise functions. You've got to do the test, okay? So for my people who weren't here, somebody help them out. What's the first test again? Plugging it in. I'm going to say -5, I'm going to plug it into my function. Piecewise, you got to recall, lesson 1, we did this. Which piece is -5 going to go into? The second one, because it's equal to -5 in the second one. So what's the y value when x is -5? 7. Is 7 a real number? So it exists, correct? So far, so good. Now the second test says what?
It has to
The limit.
It's the limit. I gotta look from the
Left.
left and from the right. For my people who weren't here, this is how you distinguish between the left, is a minus, and from the right. So the positive is from the right, a negative is from the left.
It's going to be -5 or 5?
-5. So if you're like, okay, well, what do you mean from the left? Think about it. Think of a number line. -5. What numbers are to the left of -5? -6, -7, -8, -9, -10. Where do those numbers lie? In the first piece. Because -6, -7, -8, they're all less than -5, aren't they? So I'm going to plug in -5 into the first piece of this piecewise function to figure out what y value we're approaching from the left. And what number was that again? It's 1. What numbers are to the right of -5?
-4.
Negative 4, negative 3, negative 2, negative 1, 0. Where is that? The second piece. And so that's going to be 7. Just talked about this. If I'm approaching from the left and the right and they're different, it is a jump. This is not continuous at negative 5. There's jump discontinuity there. There's jump discontinuity there. Now, if both of these were 1, say from the left and from the right, they both were approaching 1, then it would be removable. But if this 1 was a 7, it would be continuous. If all 3 of these numbers were the same, it would be continuous. But anytime they're different, it's discontinuous in some shape, way, or fashion. Okay? Questions? All 3 of them? All 3 of them would have to be the same in order for this to be continuous. That's what the graph looks like. And as you see in negative 5, there is indeed a jump there. Just like if I had you guys evaluate at 2, when x is 2, you would find there would be another jump as well. Okay? So,